So we're going to take a little stoichiometry review video here, or create one. And if you remember nothing else from honors chem last year, hopefully, or chemistry, hopefully you remember how to do some stoichiometry. Stoichiometry is one of the more important concepts that we covered last year. If you've forgotten totally why stoichiometry is important, all has to do with chemistry. You know, if you look on the basic scale, chemistry is happening on a mole-to-mole basis. And go ahead and click back and watch my mole conversion video where I explain that a little bit more. Okay, but that's why stoichiometry is just we've got the quantitative just aspect of chemistry here. How do I actually compare amounts and get those all together? So let's run through a couple problems just for review here and remember how to do this. Okay, so the first problem we're going to look at here, let's say I've got this balanced chemical equation of I've got nitrogen plus 3 moles of hydrogen goes to 2 moles of ammonia. And if you notice, as I was reading that, I was talking about mole amounts, okay? So the first thing is in a balanced chemical equation, these coefficients at the front are mole ratios, right? So on the most basic level, there are atom ratios or molecules. So I have 1 molecule of N2, okay, reacting with 3 molecules of H2. And when that chemical reaction happens, what I produce is I produce 2 molecules of NH3. Okay, but of course, you know, when we see reactions and stuff, we're not seeing them on this small of a scale. Okay, you're not actually watching, you know, 1 molecule or 2 atoms of nitrogen reaction. We're seeing, you know, magnitude larger, and how we account for that is moles, right? We're counting how many atoms we have with moles or how many molecules. So if you notice when I was reading the equation, if you remember, I'm going to say these are mole ratios at the front. I'm going to say, hey, this is 1 mole of nitrogen. It's going to react with 3 moles of hydrogen, okay, to produce 2 moles of ammonia. So let's come down and let's do a stoichiometry conversion here. Let's say, well, what if instead of 1 mole of nitrogen, okay, what if I started with 2 moles of N2? Okay, how many moles of NH3 could I produce? So let's take a look at that. All right, well, back to my balanced chemical equation, I've got this ratio, right? I know for every 1 nitrogen, I can get what? I can get 2 NH3s. So in this case, if I were to start with 2 nitrogens, then I can get what? I can get 4 NH3s. Or if you want to see the math behind that, we got 2 moles of N2. Get my dimensional analysis out here. I know I want to cancel out moles of N2, so I'm going to put that in the bottom. I know I want to go to moles of NH3 for my balanced chemical equation. I know that for every 1 mole of N2, I get 2 moles of NH3. My moles are going to cancel, and we get 4 moles of NH3. So that really is stoichiometry right there. We're using balanced chemical equations with their mole ratios to convert from one substance to another substance. So let's draw that. Let's rewrite that equation. Let's come down here and let's do a little bit something else with it. So we've got 1 mole of nitrogen. It's going to react with 3 moles of hydrogen to produce 2 moles of NH3. Now, really, this equation's at equilibrium, but we won't get into that today. Okay. So now, oftentimes you don't measure things in moles because I can't go up to something and count, oh, I've got 2 moles of that. You know, it'd take lifetimes and millennia to count that. But we can measure in grams or other things depending on if it's solution or gas. But let's say we've got this problem. Say I've got 5 grams of nitrogen, and I want to find, okay, how many grams of NH3 can be produced. Well, here's where stoichiometry is going to come into play, and we're going to compare these things. So first off, I'm in grams. Okay, I cannot compare grams of nitrogen directly to grams of NH3. The only way you can compare chemicals is through moles, right? because 5 grams of this is not equal to 5 grams of this, right, as far as a quantity or numbers of particles I have. Right? And since chemistry is happening on that atom-to-atom basis, I need to know how many atoms I have or how many molecules I have. So if you remember back to last year, I gave you a little chart to cheat here. So at the top of this, we're going to have grams. In the middle, we're going to have molar mass. And at the bottom here, we're going to have moles. Okay, so I want to draw this chart in here. I'm going to say, hey, here's my little chart. Let's fill in what I know and where I want to go. So first off, I'm given that I have 5 grams of N2. So I'm going to put 5 grams right here. Anything else do I know? Do I know how many grams of hydrogen? Well, I don't say anything about hydrogen. Do I know how many grams of NH3 I have? Well, no, but that's my question. How many grams of NH3? So I'm going to go ahead and put a question mark there to know that, hey, once we make it here, we've got our answer. Molar mass. Can I determine the molar mass of N2? From the periodic table, I know nitrogen has a mass of 14. I've got 2 of them, so I've got 28 grams per mole. Hydrogen, we got 2 grams per mole. And over here, ammonia, we're going to have 17 grams per mole. And with this table, if we remember, and the reason we set it up like this to give you a little path to how to go. I can't go from grams to grams, but I can go from moles to moles, okay, using my mole ratios. So I got to get down to moles. So what I'm going to do is I go down the table, I'm going to divide. Okay? So we've got 5 grams divided by 28 grams per mole. My grams are going to cancel, and what I'm going to be left with is 0.18 moles. So I'm going to put that over here. So I've got 0.18 moles. Okay. Now, how do I go from moles to moles? We go back and we use that mole ratio we talked about earlier. And I know that for every 1 N2, I'm going to get 2 NH3s. So in this case, if I have 0.18 moles of N2, I'm going to do 0.18 moles of N2 times my mole ratio, which is a 2-to-1 mole ratio. And I'm going to come out with that I'm going to produce 0.54 moles of NH3. So I'm going to put that right here in my chart. So 0.54 moles. Okay, so now we're doing good right here. We've compared two chemicals through moles. I've said, hey, I started with 5 grams. That's going to give me 0.18 moles of NH2. Okay, I've converted from moles of NH2 over here to moles of NH3, but I haven't made it up to my question mark up here. Okay, so if I haven't made it up to my question mark up there, I know I've got to keep going. Well, so now I want to go up my chart. And if down my chart I divide it, well, if I'm going up the chart, I'm probably going to do the opposite. So I'm going to multiply as I go up this chart. I'm going to take this mole amount, 0.54 moles, and I'm going to multiply it by 17 grams per 1 mole. My moles cancel out, and what am I left with? Well, I'm left with grams, which is nice because what am I trying to solve for in this row? I'm trying to solve for grams. And when you do that, what you come out with is you will produce 6.12 grams. So I'm going to go ahead and put that right here, 6.12 grams. And I've solved my problem. Okay, so what's our path here? How do we solve these stoichiometry problems or mole conversions using a balanced chemical formula, right, or equation? And remember, your chemical equation has to be balanced, because if you don't have a balanced chemical equation, well, you don't have your mole ratios correct. So let's go and take a look at this path. Okay. You can really start anywhere on this. You can start in moles and you can convert to grams. You can start in grams like we did and convert down into moles. So in our case, we started with 5 grams of something. We went ahead and filled in the molar mass for the entire table. Okay. You can always do that. Even though we didn't use hydrogen here, I can still find the molar mass from the periodic table. So I went from 5 grams, I went down to moles by dividing the grams divided by the molar mass, gave me moles. Then I use my mole ratio to go from 0.18 moles over here to 0.54 moles. And then once I get into moles, I can go back up to grams. Now again, if you're struggling with these individual gram to mole and mole to gram conversions, go ahead and watch that take a look at that mole conversion videos that I have posted up on my channel. So there's a quick overview of stoichiometry. All right, that's something you will have to do a lot this year. Hope this was helpful.